Okay, so you feel it, and then you stretch it, and it's super hot. All right, and then you let all that heat dissipate, and then you let it go, and it's super cold. Okay, so I was just about to pay out on Veritasium for yet again clearly describing London dispersion forces and calling it a van der Waals force, and he did it here. Excellent description of London dispersion force, and he called it a van der Waals force. But I'll forgive him for that because he's come out with something I can't believe no science teacher's ever told me about or I've ever heard about. You can just create and destroy forces and get the exo and endothermic reaction just with a balloon. So I've got that in slow motion there. So what's going on is as you stretch the rubber, it gets stronger and stronger because the London dispersion forces are forming between the hydrocarbon chains. And so making of forces releases heat. And it's really hot. And then you just go in the reverse. They're called crystallites. And then when you unstretch it, so that's all hot, but then it quickly dissipates out into the air. And then so it gets back to room temperature. And then if you bring it back to the normal state, the bonds are then broken, and breaking bonds requires energy. And it's super cold. Amazing. Okay? Can't believe I've taught science for this many years and never came up with a demo that was so easy. Okay.